Okay, hello guys, welcome back to Smarter R. So today we will learn how to calculate ETCCDI index by using R for extremely heavy rainfall, which is R25. So for extremely heavy rainfall, you can calculate yourself how you want to define extremely heavy rainfall for your place. So this is actually based on the uh, percentile, 95 percentile. So, but in my case, I will use 25 millimeter. So, if there is any days that has higher than 25 millimeter, I will consider that day as having a extremely heavy rainfall. So this is a definition for ETCCDI index for extremely heavy rainfall. This is subjective. Every place and any place have different definition for extremely heavy rainfall. It can be R25, it can be R27, it can be R30. But the last time I tried to calculate extremely heavy rainfall, I use a percentile for that particular area for many rainfall, and then if the mean is R25, I will use R25. So let's go straight to it. Let's calculate extremely heavy rainfall for ETCCDI indices. So we load the required libraries for data manipulation and depth handling, which is dplayer and lubridet. Dplayer and lubridet. And then we set the working directory where we put our data set working directory. So I put my directory in this folder. So my data set is in this folder. Just copy this folder directory. So I read this set working directory. And then I read the CSV file with CSV. So we have a CSV file with this name, chips JRB grid 005, with the header to as a variable date. So the variable will be date. I put this as date, the CSV file with the header 2. So this data set is this one. Okay, chip JRB grid 005. So this is our data set. We have year, month, and day, and our daily rainfall for each grid point. You can replace this grid point with your station data, not a problem. So we have daily rainfall data. So we have daily rainfall data. So from 1981 to 2021. So my data I have about 1981 to 2021, more than 30 years for climate assessment. It must be higher than 30 years. So this is our data. I arrange it like this: year, month, and day, and the rest is each grid with the daily data. Or if you want to use station data, you can just arrange your station data for each station data. So I have grid V1 until V109 here. So I will read this date, read my data set. After that, step 4, we convert year, month, and day columns to date format. So by combine year, that month, and date 3 for column 1, column 2, and column 3 just now, we create a new date column by using paste and as date function. Paste and as date function. So we use date, $sign, and date, and then we convert year, month, and day column into a date format. After that, we create a data frame to store the annual R25 result. So we annual R25, we put it into create an empty data frame with the year column containing unique years from the original data. We have unique years from the original data. We create a empty data frame to store. We create a data frame to store the annual R25 result. Okay, now we go to step 6. We define the function to calculate the R25 value for a given vector of precipitation value. So we calculate R25. So here is the calculation for function precipitation vector. So we sum for each occurrence that have rainfall higher than or equal to 25 millimeter. We sum it for that particular year, and we use na.rm to equal to 2. This one is to handle the missing data. So we calculate the sum for each year that have rainfall higher than or equal to 25 millimeter. So we calculate R25 here. Now, after we calculate R25, we loop through each column just now, each grid point, because we want to calculate everything in one go. We don't want to calculate one by one. That is very tedious exercise. We use loop to run everything in one go. So by using this, we loop to each column, and then we nested the loop to calculate R25 for each year and each column. So we loop to each column here from V1 to V109 to calculate the number of days. So we have our data set grid 1 to 109 is located at column 4 to 112 just now. So it starts from column 4 until 100, column 112. So we assume the column index is here, 109. So here we calculate the number of days with precipitation greater than or equal to 25 millimeter for each year. So for each year. So we run step 7 to 8 concurrently, and then we go to the last step, step 9. We save the annual 25 millimeter result to a CSV file. So we write .csv. This is our calculation just now, annual extremely heavy rainfall 25 mm. We create a new CSV file. But this is our output, R25 set.csv, and row names equal to false. We don't want to read the row names. So we run it, and then we get our result. Okay, now it's calculate our result. Our result is here. So as we can see, we get our result for the every year, annual extremely heavy rainfall. How many days in a year there is a extremely heavy rainfall? For example, we have grid 1 here. In 1981, we have 13 days that has a rainfall higher than 25 millimeter. And for example, here also we can see some of the high value. Here 23. In 2008, we have 23 days that has higher extremely heavy rainfall. So extremely heavy rainfall 23 days in 2008. Maybe this is during the La Nina. So this is the unit for R25 extremely heavy rainfall for ETCCDI index is days. It is days. Calculate the value here is days. So I hope everybody understand here. For example, for grid 4 here, we have 14 days in 1981 that has a rainfall higher than or equal to 25 millimeter. So that is how we calculate extremely heavy rainfall R25 in ETCCDI index. But keep in mind, extremely heavy rainfall is subjective. You can change the value here to 30, and in this code you can change it to 30. For example, here when you calculate the precipitation vector here, it must be higher or equal to 30. But in my case, I'm decide it as 25 millimeter. Or if you want to make another value, beyond extremely heavy rainfall, maybe you can put maybe 35 or 40, something like that. But the value might be very small. The occurrence of days with that maybe 40 millimeter per day is very small, but it might be happen. Okay, I think that's all for tonight. Thank you for watching.